So previously we've learned how to find profit maximization level of output as the distance between total revenue and total cost. We've tried to maximize the vertical gap between these two curves. We've found how to derive total profit curve, how to construct it, and how to find the level of output where this profit is maximized, where we reach a peak on the total profit curve. Today we will work on the second technique using marginal and average curves, which is more common. And the first stage which we'll need to implement is to find profit maximization point where marginal revenue is equal to marginal cost. As I mentioned in the previous lecture, this is the most important rule in microeconomics, and we will simply need to memorize this rule and follow it. This will allow us to find the best possible level of output, which will generate highest possible profit for the company. So first step is to find the point where marginal revenue equals to marginal cost. Let's do it. So this is our marginal cost curve. It's a U-shaped curve. As you know, it goes down initially, reaches point of minimum where the law of diminishing returns kick in, and then it goes up. So for majority of levels, possible levels of output, marginal cost will be increasing. Then we add our marginal revenue line, and as we've learned previously, marginal revenue line for the linear demand curve is the line which can cross horizontal axis and become negative, because total revenue can increase or decrease depending on elasticity of demand. So marginal revenue can be negative. The point where they cross will be represented by this point E. This is the point which will determine the optimum production level. So as long as we know how our marginal cost and marginal revenue line looks like, we will be able to find profit maximization point E in this case. And our profit maximization level of output would be 3 units. If we produce 3 units, we can ensure that our profit will be maximized. This will be the highest possible level of profit for our company. Next, second stage. After we've discovered how much we need to produce, let's work out what specific profit we will be able to make. And to do this, we will use average revenue and average cost curves. So let's add an additional curve, which is our demand curve. Demand curve is simply average revenue, or the price which we can get by selling different number of units. Demand simply shows the relationship between quantity and price which consumers are prepared to pay for different amounts of output. For example, if we offer them 3 units of output, they will be prepared to pay somewhere here, some of this amount. They will be prepared to pay at this particular point, this amount. Apart from this, we can also add average cost curve. As we know, average cost curve has a U shape. This is what we've studied last week. And we will also learn that it will have a point of minimum exactly at the point where it crosses marginal cost line. So we need to draw it correctly. Next. As we know, we need to produce at this particular point. This is level of output where marginal revenue, purple curve, crosses marginal cost, red curve. So we will need to produce 3 units of output. This is our desired level of output. However, we still don't know what price we will charge, because we should not be charging this particular price below £4. No, in fact, we should increase the price all the way up to demand curve, because only demand limits how much consumers will be prepared to pay. There is no point charging less than £4 when consumers are prepared to pay a higher amount. Demand curve, green line, shows us how much consumers will be prepared to pay for 3 units of output. So what we'll need to do, we'll need to go all the way up to point A on the demand curve. And this point will determine the price charged, while point B on the average cost curve will determine how much it would cost us per unit to produce this number of units. In this particular situation, we can see that point A is at £6. In other words, when we produce 3 units of output, we can sell them at £6 each. While average cost curve, the blue line, and point B on this curve tells us that the cost of production of this level of output will be £4.50 per each unit. In other words, we produce 3 units, we sell them at £6, and each of these units cost us £4.50, which actually means that our total profit, which we are going to make, will be shown by this shaded rectangle. We make £1.50 per each unit, times 3 units. So we take vertical distance, multiply by horizontal distance, which will give us the area of this rectangle. This rectangle represents total profit made by the company. And in fact, it is the highest profit which can be made in this particular situation with this level of demand which we are facing and with this particular cost structure, 150 per each times 3 units. So total profit will be 450 in this particular example. We've discovered the number of units we need to produce as a point where marginal cost crosses marginal revenue. This determines our output, and price is determined by the demand curve, by point A on the demand curve. Next example. What if the company is making a loss? How can we minimize the loss? What is the loss minimization case? How can we find it on a graph? If the company is making losses, it can still operate at a point where marginal revenue equals to marginal cost. By choosing this level of output where marginal revenue is equal to marginal cost, it will ensure that its losses are minimized, that it's not losing too much, it's not losing more than necessary, unless the price drops below minimum of average variable cost, and in which case it should shut down production altogether. We'll come back to this later. So in other words, in order to maximize profit or to minimize losses, we still need to choose a point where marginal revenue equals to marginal cost. Let's have a look at the graph. As before, this is our demand curve, and this is our marginal revenue line. This is how they should be drawn, as I've mentioned several times already. They originate at one point, but marginal revenue is steeper and it crosses horizontal axis. Then we add our marginal cost line and average cost line. And please pay attention, demand in this exercise, in this particular example, is relatively low. It's quite close to the origin, and for any range of output, our demand is below average cost. So strictly speaking, regardless of how much you choose to produce, your cost of production, purple line, will be higher than green line, than what consumers are prepared to pay for this particular product, which means that you will be making losses. Consumers will be paying you less than the cost of production of your output. So how much you will need to produce in this particular case? As before, we select the point where marginal revenue, blue line, crosses marginal cost, red line, which will be this blue dot. This will determine our optimal level of output, our production level, shown by Q. Next, green dot on demand curve will determine how much we will be able to charge for our product, because demand limits the price we can set for our products. Consumers are only prepared to pay this much for this level of output, not more. They cannot pay more, and there is no point for us charging less, because consumers are prepared to pay this very amount. So this green dot will determine how much we will charge for our products. P, green letter P, this is what we'll charge. And the purple dot on the average cost line will determine how much it costs us to produce this level of output per each unit. And as you can see here, average cost of production is higher than the price which we can afford to charge. Consumers are prepared to pay us less than what it costs to produce these units. In other words, we will be making these losses shown by this red shaded area. Cost of production per unit are higher than the price. We are losing this amount per each item made times number of items, and the whole area will represent the total loss which we are suffering. You can ask a question, why don't you shut down altogether? Why do you have to produce this level of output if you're making losses? Why don't you close your production? Why do you still operate in this loss-making situation? The answer is fixed cost, because you are suffering from fixed cost regardless of whether you produce anything or not, because you will need to pay your rent, for example, or bank charges regardless of how much output you will need to produce. If you shut down your production, as you are stuck with a certain amount of capital, with a certain amount of fixed costs to pay, you will have no revenue, no income whatsoever to cover these costs, yet you will still need to pay them. By producing some level of output, some amount of output, you will get at least some revenue, some cash flow to cover this expenditure, this fixed unavoidable expenditure. And by producing at this level of output, you will be able to generate the maximum which can be done in this particular scenario. If you shut down altogether, you will have to suffer the loss which is equal to your total fixed cost of production. If you produce at this level of output, which is optimal from the economic point of view, your losses will be lower. Your total loss will be lower than total fixed of production. In the seminar, we'll go through some examples which will shed further light on this, and hopefully you will be able to understand this better. In any case, when you want to maximize your profit or minimize your losses, you need to operate at a point where marginal revenue equals to marginal cost. In other words, at a point where these two curves cross each other.